Alright people, question 4, another question that was done pretty poorly, especially in part C and part D. 4A and 4B, majority of you did well, so I've already written the answer to that. You just had to use the formula booklet for the scalar product or the dot product, and that gave you 2 plus 4k or 4k plus 2, and then you do it for OB and OC. So if you think about it like that, you got your two vectors. Here's O, here's B, there's C, and there's O, and there's A, and there's B. That's just a rough sketch in there. So that gives us the scalar product, which, remember, if you were to shine a light, it would be the work done to there. So then the tricky part that I think all of you got wrong, or I think maybe Anson might have picked up the most marks in this one. So from here, the first part that you would get a point for is stating that if angle AOC equals the angle at BOC, then that means that cos AOC is also equal to cos BOC. So because the angles are the same, then that means that the cos of both is going to be the same as well. And then we remember our formula for cos theta, which is in the formula booklet. Cos theta is equal to A dot B over the magnitude of A times the magnitude of B. So then I need to think about my formulas in terms of AOC and BOC. Well, I need to get the magnitude of OA, so that's what I've done here. Magnitude of OA was 6, magnitude of OB was 10, and the magnitude of OC was the root of 1 plus k squared. Now, what's important to realise is it says that show that k equals 7. You cannot substitute the value of 7 in for k at any point, because the whole point of this is to show that k equals 7. So I'm not going to substitute that 7 in. So I've got all my magnitudes. Now I can go to the formula, which is here. So on the top of the left hand side is A dot B for OA and OC, which I got in part A, 2 plus 4k, over the magnitude of OA, which is 6, times the magnitude of OC. So that's the left hand side here. Then on the right hand side, so this is the left hand side, this is the right hand side. So on the right hand side now, the scalar product of the numerator is A 8k minus 6, so that was OB dot OC. And on the bottom I've got 10, because that's the magnitude of OB multiplied by the magnitude of OC. So that would have got you about 4 points to this stage. Then I'm just going to rearrange. So someone was very close to doing this, but they just forgot that if I bring the denominator here up here, then it's going to multiply by this. So have a look here. So 2 plus 4k equals, so I'm only bringing the denominator of that one up, and then I end up with 8k minus 6 multiplied by 6 multiplied by root 1 plus k squared, all over 10 1 plus k squared. And the reason I didn't bring the 10 up to the side is because what I can do now is, because this is all multiply, I can just cancel this out, and that eliminates the complex radical with 1 plus k squared underneath. So by cancelling them out, what I can now bring the 10 up here, so it ends up being 10 times 2 plus 4k equals, and then I've got 6 times 8k minus 6. So just by doing that little step of bringing the 6 root 1 plus k squared up here, I was able to just cancel that complex part, and it made it much simpler. So now I've just got a linear equation. So that's going to give me 20 plus 40k is equal to 48k minus 36. So then I'm going to get 20 plus 36 is equal to 48k minus 40k. So therefore 56 is equal to 8k, so k is therefore equal to 7. So therefore it's shown. So again, everyone had the capabilities of doing that. You just let something a bit unfamiliar fool you in the way that it was written, that's all. You all had the skills to solve that problem. And I think it might have been Lou who managed to get to this bit, but then she just didn't rearrange correctly. So that is that proven, showing that k is equal to 7. Then it says calculate the area of triangle AOC. So if this is O, this is A, for example, and this is C, just a rough sketch. That would be the triangle. And I know from vectors and from area of triangles with trig that the area is equal to a half A B sine C. So if I put that into perspective of the triangle, it's going to be a half times the magnitude of OA times the magnitude of OC times sine of the angle AOC. So what do I have? I have the magnitude of OA, which we seen above was 6. So I'm just going to put that in as times 6. And we have the magnitude of OC, which we know here, magnitude of OC, bearing in mind that k is 7, so it's 1 plus 49. Which equals root 50. So root 50 times, and then sine AOC. So the problem is finding the sine AOC, which is this angle in here. But what we do know is that cos AOC if we simplified it down and put in the 7, is 2 plus 4k over 6. And we know that the magnitude for OC now is root 50, so I no longer need to put root 1 plus k squared. I can just do root 50, which is therefore going to equal, well, k is equal to 7, so that's going to be 2 plus 28, so it's going to be 30 over 6 root 50. So if we simplify that, we're going to get 30 divided by 6, it's going to be 5 on the top and root 50 on the bottom. So now you need to remember the rule that sine squared theta plus cos squared theta equals 1. So sine squared theta equals 1 minus cos squared theta. So sine theta equals the square root of 1 minus cos squared theta. So if I do this at the side, well, cos theta, or AOC, is 5 over root 50, and cos squared theta is equal to that squared, so that's going to be 25 over 50, which simplifies to half. So now that's a half, I can go back here and state that sine AOC is equal to the square root of 1 minus a half, which is equal to the square root of a half, which is equal to 1 over root 2. So sine AOC is equal to 1 over root 2. So that was a tricky bit. Then back up to the main equation, which we wrote at the beginning here. So if I just do this down at this bit, finish off, area is equal to a half times 6 times root 50 times sine AOC, which we said is 1 over root 2. And now calculate our answer. So it's going to be 3 and then times root 50 over root 2, which is going to be 3 root 25, which is going to be 3 times 5. So the area is equal to 15. And you could write units squared. Voila. So yes, 6-mark question. Don't think anyone managed to get anywhere close to the area being 15. And this one here was an 8-mark question, which I think Lou did the best at, but she only got to, as I said, here, and then wasn't able to rearrange it. Hopefully you're all sitting there kicking yourselves. You should be.